My name is Li Jiajian. I am from RK08 Mechanical Engineering. Thermometer is the instrument we had chosen in this assignment to study about how a thermometer is gonna work and how does it related to the thermodynamic principle that we learned in this semester. So thermometer is an instrument for us to measure the temperature of liquid. We dip the thermometer into a liquid and there will be a heat transfer from the liquid across the boundary of the thermometer into the mercury. Basically, thermometer works on zero law of thermodynamic. So what is zero law of thermodynamic? Zero law of thermodynamics states that if A and B are in thermal equilibrium, at the same time if B and C are also in thermal equilibrium, then A and C will also be in the thermal equilibrium. We consider A is the body of which you want to measure the temperature, and B is the bar of thermometer, and C is the mercury. In this way, the rise of the mercury indicates that the temperature of the fluid. Next, my friend will tell more in details about how does a thermometer work. Thank you.
The topic that I present is how thermometer works. There are various types of thermometers. The thermometer that we are familiar from the science class is the thermometer consists of a liquid encased in the narrow glass column. Our thermometer is using liquid mercury. In response to our understanding of the health concerns associated with mercury exposure, the liquid mercury is replaced with liquid alcohol. Liquid thermometers are based on the principle of thermal expansion. As the temperature of the liquid in a thermometer increases, its volume increases. The liquid is enclosed in a tall narrow glass column with a constant cross-sectional area. The increase in volume and thus in the height of the liquid column is proportional to the increase in temperature. 10-degree increase in temperature causes a 1 cm increase in the column height. Then, 20-degree increase in the temperature causes a 2 cm increase in the column height. And 30-degree increase in temperature causes a 3 cm increase in the column height. This shows linear relationship between the temperature and the column height. The calibration of the measuring tools involves the placement of division or marks upon the tool to measure a quantity accurately in comparison to known standards. The tools needs division or mark scheme. For instance, a meter stick typically has markings every 1 cm apart or 1 mm apart. This marking must be accurately placed, and the accuracy of their placement can only be judged when comparing to another object that is precisely known to have a certain length. Thermometer is calibrated by using two objects of known temperature. The typical process involves using freezing point and the boiling point of the pure water. Water is known to freeze at 0 degrees Celsius and boil at 100 degrees Celsius at an atmospheric pressure at 1 atm. Since there is a linear relationship between the temperature and the height of the liquid, the division between 0 degree and 100 degree can be equally spaced. With a calibrated thermometer, accurately measurements can be made of the temperature of any object within the temperature range for which it has been calibrated.
I've always find it a bit odd whenever I would come across temperatures in Fahrenheit. I would have to essentially rack my brain around the conversions to truly have any intuition for it. I mean, why does water freeze at 32 degrees? And what is represented by 0 degrees on the Fahrenheit scale? Well, according to numerous sources, the Fahrenheit scale was defined by giving the temperature of an ice, salt, and water mixture a value of 0 degrees. And 100 degrees will be roughly the internal temperature of the human body. But that is not entirely true. The actual story has a little more to it than that. To learn about how the Fahrenheit scale was devised, we would have to take a look back in time.
Marty, you made it!
Yeah!
In 1701, after the death of his parents, a young Polish boy by the name of Daniel Gabriel Fahrenheit went to Amsterdam to work as an apprentice bookkeeper. But young Fahrenheit wasn't too pleased with his job. He ran off so many times that his employer had asked for an arrest warrant to be issued. 1708. While Fahrenheit was traveling around Europe to escape from his employer, he became fascinated with scientific instruments, particularly thermometers. And somewhere down the line, he met with the mayor of Copenhagen, possibly seeking asylum, who at the time happened to be the famous astronomer Old Romer. Now, Romer's work in astronomy was how he gained recognition in the scientific community. But more pertinent to this story is that Romer had came up with a temperature scale of his own at a time when he was stuck in his living quarters due to a broken leg. This temperature scale has the freezing point of water set to 7.5 degrees and the boiling point of water to be at 60 degrees. Now, this might seem a little random until you consider the fact that Romer was an astronomer and so was accustomed to dividing things by 60. So now if you take this temperature scale, divide it in half, then half again, and half once more, you'll find the freezing point of water to be 1/8 of the scale and human body temperature to be 3/8 of the scale. When Fahrenheit learned of Romer's temperature scale, he made an adaptation of it, adjusting slightly because in his words, he found it to be inconvenient and inelegant on account of the fractional numbers. So he changed it to 8 and 24. And this would be the original Fahrenheit scale. But up to a later point, he scaled all the numbers up by a factor of 4, making the freezing point of water to the familiar 32 degrees and body temperature to 96. Now there's very little documentation on why he did this. Fahrenheit was an excellent instrument maker. His methods were so fine-tuned that the thermometers he produced were shockingly consistent, which at the time was a monumental engineering feat. He pioneered the use of mercury as a measuring liquid which has a much higher boiling point compared to alcohol, which was used in most other thermometers at the time. In his works, it's possible that he noticed a 1 degree increase in temperature corresponded to its specific fractional increase in volume of the measuring liquid. And today we know that a 1 degree Fahrenheit increase in temperature increases the volume of mercury by exactly 1 part in 10,000. Was this intended? Or perhaps just a coincidence? We'll never know, because as an instrument maker, Fahrenheit was very secretive about his methods. In his day, the Fahrenheit thermometer was the best you could get with your money. But now his scale is only ever really used in the Cayman Islands, Bahamas, Belize, and the United States of America. So maybe it's about time we all agree on the universal scale of temperature, Celsius, which, by the way, wasn't invented by Celsius. But that is a story for another time.
My name is Yong Jiashun from RK08, and as my group member has already talked about the contents, so I will talk about the conclusion. as the conclusion, we can conclude that thermometer is very useful and it used very wide range in industries, scientific research, and even healthcare. Today's specialized thermometer used for variety of purposes. For example, the steel industry used parameter to measure the temperature, iron and other metals, and also astronomers use infrared thermometer to detect the infrared radiations at great distance and correlate to its surface temperature. In addition, now the research at Harvard University has developed a nano thermometer which is able to measure the temperature variations at a single living cell. This nano thermometer has injected with a nano crystal which can detect incredibly small fluctuation in temperature. So now the scientists are now developing nanocrystal technologies that can change cellular temperatures. This technology may ultimately be used in medical treatments that overheat and kill cancer at the cellular levels. So I will end here. Thank you.